teach you about correlation and scatter plots. So first I have a question for you. What do you think is the relationship or the connection between the amount of time you study and your test grades? Take a moment to think about it, and then pause the video, unpause when you're ready to discuss it. So how do you think this data would look on a graph, for example? So we put average study time on the x-axis because it's our independent variable. And we could put test scores on our y-axis because it's our dependent variable. So what kind of relationship do you think exists between average study time and test scores? There are three possibilities. First possibility is that there's a positive relationship. So as x increases, so does y. So as average study time increases, then test scores increase. Or perhaps there's a negative relationship. As x increases, y decreases, and vice versa. So at the more time we study, the test scores drop. Or perhaps there is no connection. So x and y have no connection. So it doesn't matter how much time you study, it will not have an impact on your test scores. This brings us to the idea of correlation, or to correlate. To correlate is to have a mutual relationship or connection in which one thing affects or depends another. And that's from dictionary.com. So if we look at these, the correlation graphs, which are these scatter plots, as the negative sloping line would be a negative correlation. The positive sloping line would be a positive correlation. And then if we have no correlation, we might either have a horizontal line where these dots just look scattered and they look random. Now the strength of the correlation, it is basically what it sounds like. It tells us how strong that relationship is between those variables. And so you can look at it on the scatter plot. If we were to draw a line of best fit, which is this sort of trend line or average line at the middle of our data, the middle of all these dots, the stronger the correlation, the closer those lots will appear to that average line. And the weaker the correlation, the further away the dots will appear to that line of best fit. So if we had a perfect correlation, so if we had a perfect correlation, then all of the dots will be on the line. And as we move away to no correlation, then those dots will be scattered around the line at a great distance. So in terms of, there's a statistic that can be calculated, which is called R, or regression, and that means correlation. So if R is above 0, it's considered a positive correlation. And if it's below 0, it's considered a negative correlation. And it turns out that the range of R, or the range of correlations, is between -1 to 1. So a correlation of 1 would be the strongest positive correlation that you can have. And of course, a correlation of -1 would be the strongest negative correlation you can have, and a correlation of 0 would of course be no correlation. So there are also cutoff points, or generally accepted cutoff points for strength. So once we reach 0.8 to 1, now we're saying that's a strong correlation. So it can either be positive 0.8 to positive 0.1, that would be a strong positive correlation. Or if we had negative 0.8 to -1, that'd be a strong negative correlation. Now medium is from 0.5 and right under 0.8. So negative 0.5 to negative 0.8 would be a negative medium correlation, and 0.5 to 0.8, right below 0.8, excuse me, would be a medium positive correlation. And then of course our weak correlations would be anywhere between negative 0.5 to positive 0.5. Now let's make a transition. I would like to show you how to make a scatter plot. So I'm interested in finding out the correlation between two variables, creating a scatter plot as well. So the first thing I want to do is I have this data I want to compare the height, person's height to their shoe size. So if I look through this data, it's hard to make sense of this. It just looks like random numbers here. So what I'm going to do is I'm going to create a scatter plot. Now, in order to do so, I have both of my variables next to each other. So I'm comparing height and shoe size. And the one on the left is going to go on my horizontal axis, my x-axis, and the one on the right is going to go on my vertical or my y-axis. So I make sure that I have my variables where I want them. If I wanted, for example, shoe size to be on the x-axis, I can just drag it over. But I'm happy with having height on the x-axis. If there was another variable, let's say on the spreadsheet, I would have to highlight it and drag it next to the variable I'm interested in. But this is fine the way it is. I'm going to highlight both columns, insert, chart, and go up to charts, click on scatter, click on this image here, and you can see that it gives me a preview of my data. You can see that it looks like a positive correlation there. I want to add more information, so I'm going to click on customize. I want to give it a descriptive title. After I give it a title, I want to title the horizontal or the x-axis. So I'm going to give it a name. So I believe this was height. This was in centimeters. Now we're going to label the vertical axis, shoe size. I can also get rid of the legend if I'm interested in getting rid of shoe size, and that would be none. Or I can move it around, go to insert, and then I have my scatter plot here. Now, so this looks like a positive correlation. If I was to draw something called a line of best fit, it would go somewhere over here. But to give me a good idea of where I want to draw this line of best fit, which is basically the average line, shows the average of the data, what I can do is I can put in a formula. So what I'm going to do is I'm going to put equal sign. Whenever you put equal sign, that means there's going to be some kind of formula. And start typing correlate. See? Correlation. Now, opens a parentheses. I'm going to select this column, so all of B. Then I'll put comma. Then select the other variable I wanted to compare it to. Close parentheses. Return. And it gives me my correlation. So this correlation is 0.71 or 0.72. So that tells me it's a positive correlation, which it is because the data is sloping up. And it tells me that it's a medium correlation. Not a strong correlation, but a positive medium correlation. So I want to add my line of best fit. So what I need to do is I need to save this graph. I'm going to say save image. I'm going to save it to my desktop. Give it a title. Save it. So now that I saved it, I'll be able to edit it. So let me minimize this. Find my graph. Here it goes. So I have this. I can add a line of best fit by clicking on this here, and I can add a line. I can change the color if I wanted to. And it looks, you have to make sure the line of best fit is right in the middle of your data points. And it should start where the data starts. It ends when the data ends, so don't go past your lines. That looks pretty good. So roughly half of my data points are above the line and half of my points are below the line. No need to extend all the way here. We don't have data here. No need to go all the way through here. So this is my line of best fit, which basically gives me good information about these variables. This nice sloping line is sloping up. We have a positive correlation, and that's scatter plots and correlation. Thank you.